Hey everyone, let's start with question number 8, Digital Electronics asked in GATE Examination 2025 Instrumentation Branch. A 4-bit signed 2's complement form of 5 base 10 plus 5 base 10 is. Let's start writing the solution using the more generalized form is form for finding 2's complement. Write the binary representation of the given number. It is 5 base 10 plus 5 base 10. So you can write as 10 base 10. So for binary representation it is 1010 base 2. 4 bits are the minimum bit required for binary representation of 10, and it is asked in question 4-bit signed representation. Now writing the bits far apart so that you can understand. Copy this bit as it is. This is your sign bit, and the rest of is your magnitude part. Invert these bits so that you can get the 1's complement form 101. Now add 1. You will get carry 1 1 1, and this is as it is copied. What is your MSB bit, which is 1, and what is your rest bit are your magnitude part. This comes out to be 6, and this is your minus, which is decimal 10. So this is your answer of this question. There is one key point you should know, that 2's complement representation is given for negative numbers. You should remember this. I'm not saying that you cannot use the 2's complement representation for positive numbers. For an example, I wanted to say that for a positive number you should write 0 1 0 1. This is a positive number. You can see from its MSB bit it is 0. It is a positive number. So 2's complement representation is as same as the original representation. But for a let's say for this question it is written as 1010 1010. The 2's complement representation is 1110. So it is very much preferred to write the 2's complement representation of a negative number who's having the MSB weight as 1. There is one more method to find the 2's complement form. You must have a practice on this method as well. This is sometimes takes less time. Start from LHS. I will give you an example. Let's take the same example 1010. So write the bits as it is from the LHS. We are copying until you get your first one. Once you got your first one, start inverting the bits. Invert this bit, invert this bit and this bit. Now this complete bit is your magnitude, and you should place a negative sign. As you already know, that from the MSB that this is your negative number. MSB is minus, MSB is 1. So this is your, comes out to be your negative number. So you must remember placing a negative sign, and your complete this bit is your magnitude part. I will give you one more example. This is sometimes a special case also referred as 1 0 0 0. So this trick is also valid on this case as well. Start writing the bits from the LHS as it is until you get your first one. It is right 0 0 0. You got your first one. Stay here. Write the magnitude part, which is comes out to be 8. You know that from the MSB that it is 1, so it is comes out to be a negative number. So it is minus of 8 in decimal. So you can have here this example, one of the good example of this question. I hope you got a good idea from this question. This is a very basic question. So thank you.